Good day, gents. I once again hope all to be well. So now, gents, I want us to shift focus from the linear pattern, which we did the last time, to the quadratic pattern. But before then, I want us to just highlight a few differences between the two. So now the linear number pattern, which we did the last time, made use of the formula. So that would be this formula here highlighted. So now this formula in itself only works for the linear pattern. So the linear pattern would have a first, or rather a constant first difference. So what that means is if you had to subtract the preceding term, which in this case would be 4, from the previous term, which would be 1, you would get 3 each time. So the 7 minus the 4 will give you 3, and the 10 minus the 7 will also give you 3. So that in itself would be the linear pattern, which only has a first constant difference. The quadratic number pattern would be a bit different. So it means in this case, you actually get a second difference. So the first difference, so that would be the first difference there, will not be constant. So it means that you have to subtract further to get a second difference. So that in itself would make the pattern quadratic. So remember, you get the quadratic number pattern by having a second difference. So now the quadratic number pattern can be defined by the Tn. So that would be this Tn here. I'll just maybe use blue for it. So this Tn there will be used for the quadratic pattern. So remember, you have to have a second difference for it to be quadratic. You can also use to find A, B, and C. You can use the following equations. So now you always start from the bottom. So that would be the bottom over there. So to find A, you would equate it to the difference itself. So that would be the second difference. So that would be 2A equals 2. To find B, you would need to make use of the second equation. So that would be the 3A plus B, which would equal the first term of the first difference. Then for your C, you would use the equation A plus B plus C, which would equal 6. So now in this case, the 6 would be the first term. So you would need to do so in order to find the C. So now, gents, I want us to look at a question here. So I have a question prepared for us, and I want us to just have a good look at it. So now this is a somewhat a question that you would, a typical question that you would get in an exam paper. And I want us to just go through it. So now the question reads, given the quadratic pattern, 8, 18, 30, 44, and so on and so forth, they want us to write down the next term of the pattern. So the next term would be T5. So we need to write, we need to come up with T5. So like we said, we will need to find the first difference, then the second difference. So I'm gonna just move on to the next page for us to be able to do so. So let me just quickly do so. Next page will give us, so we still have that 8, we have the 18, we have the 30, and we also have the 44. So now if we had to find the first difference, we would subtract the 18 from the 8. That would give us a 10. The 30 from the 18, that would give us 12. And the 44 minus the 30, which will give us 14. The second difference would be 12 minus 10, which is 2, as well as the 14 minus 12, which is 2 as well. So now remember that, maybe I should have actually written it a bit further out, but it's all good. So remember that the second difference would be equal to 2a. The first difference would be equal to 3a plus b, and the first term would be equal to a plus b plus c. But then in this case, we are asked to find the next term, which is t5. To do so, we know that the first difference goes by 2. So it means that that has to be 16. And if we add 16 to 44, we should get a 60. So it means that T5 would need to be 60, which is what we were asked to find here. So it wanted us to write down the next term of the pattern. So now our 1.2 wants us to determine a formula for the nth term of the pattern. So the nth term for a quadratic pattern would be that over here. So that would be what we had there. So we need to actually write it out. So that would be 1.2. So let me just use black for that. 1.2. We will need to find an squared plus bn plus c. So we will find a, b, and c through the equations that we have here. So we will start off with the 2a. So that would be 2a equals 2. Divide throughout by the 2, and we should get a to equal 1. So we have a. So now to get b, we will equate the 3a plus b to 10. So that would be this portion here. So now this in itself, we already have the a. So we will substitute in the a, and we will find b to be equal to, so that would be 10 minus 3, which is 7. So now to find c, we will equate it to that portion there. So that would be for the c. So that's a plus b plus c equals 8. We know what the a is, so that would be 1. The b we just found to be 7, plus c equals 8. And then this in itself will just give us c to equal 0. So we can then rewrite our equation, which is the Tn. So that would be Tn equals, a was 1, so that's n squared. B was 7, so that would be 7n plus c, which is 0. So it turns out that our Tn would equal Tn n squared plus 7n, which is what we were asked here. So that would be determine a formula for the nth term of the pattern. So now our 1.3 wants us to determine, or rather it says which term of the pattern will have a value of 330. So it means we have to equate the 330 to the Tn by making use of the formula. So let's go back to the formula. So the formula itself was Tn equals n squared plus 7n. So let's move on to the next page for us to do so. So that would be 1.3. So we will just write out the Tn equals n squared plus 7n. So we were asked to find the n if Tn equals 330. So that would be Tn, which is 330, equals n squared plus 7n. So now we can then look forward to solving a quadratic. So that would be a quadratic over there. So we just move the 330 to the right-hand side. So now we can solve this by factorizing, and we can find that if we had 22 as well as 15, and that is negative and that's positive, we would have actually factorized the quadratic. So now we can then say that n would equal 15 or n would equal negative 22. Since n is a number, as in a number of things, n cannot be equal to negative. So it means that the 330 is actually the 15th term. So you can say that T15 equals 330. And I think that should be all for today. I wanted you guys to just know how to do all this, and all should be good. Gents, you have yourselves a very good day, and please do check out the vid, and it should help you with the work that will come after. A good day.